This is 2.4.5. We're given a probability density function f of x equals 1 over x times the natural log of 1.5 for x between 4 and 6. That should say 6. Let's see. And the question was for part C to find the upper and lower quartiles. So for these, we just want to set our CDF, capital F of x. So capital F of x equal to 0.25. And then again do capital our CDF f of x equal to 0.75. So again, this is our CDF, not our PDF. So I need to find our CDF. So to find your CDF, you always integrate. So you're going to integrate f of x dx, but you need to go on your actual limit. So in our case, we're going to start at 4. So ours is going to be the integral from 4 up to x, 1 over. Now you're supposed to technically put in a dummy variable like t. Sometimes I don't actually bother doing that since we're not in a calculus class, but that's what you're technically supposed to do, dt. So we want to integrate the PDF from 4 to x. And possibly when you were doing it, you weren't putting that 4 as your lower limit. Maybe that's what messed it up. But let's try. So the integral of 1 over t, well, first of all, the 1 over natural log of 1.5 might be throwing you off. So you can just bring that out. So 1 over natural log of 1.5. Integral from 4 to x of 1 over t dt. Now from calculus, you might remember the integral of 1 over x is just natural log of x. So we're still going to have 1 over natural log of 1.5 times natural log of t. And we need to evaluate that from 4 to x. So when we evaluate, we plug in the top limit first. So we have 1 over natural log of 1.5 times all of this. So we'll do the natural log of x minus the natural log of 4. So that is our CDF. You could change this all to decimals. It would probably actually make your life a lot easier. But let's go ahead and try my lower limit of 0.25. So to find my lower quartile without changing it all to decimals, we're going to set all of this equal to 0.25. So 1 over natural log of 1.5 times natural log of x minus natural log of 4 equals 0.25. And at this point, I probably will actually just switch using decimals. So I have 1 over natural log of 1.5, so let's multiply both sides by that. So we'll get the natural log of x minus natural log of 4 equals 0.25 times natural log of 1.5. So natural log of x minus natural log of 4 equals 0.10136. And now let's add natural log of 4 to both sides. So natural log of x is going to be that plus the natural log of 4, which is 1.48766. Okay, so that's the natural log of x equals that. So now we need to exponentiate both sides to get rid of that. So we'll do all of e to the power of all of that, e to the power of all of that. So we'll get x equals e to the 1.48766. So x equals 4.426. That is our lower quartile. So for our upper quartile, you're going to do the same thing, but start at set it equal to 0.75. Again, if you just switch all of this to decimals at the very beginning, it will probably be a little bit easier.